everyone, I'm Petra. I'm a software engineer at Infobip, and together with some of my wonderful colleagues, we did a research of what we could do with intent-based copilots. This microphone is standing, uh, and how to actually improve them. So, if you've ever encountered any visual chatbot building interface, because there was a rise in need for complex automated conversational experiences, brands want to enhance interactions with their users. They want to offload their customer support agents. They want something that's easy to tweak, that's easy to test and deploy, and then you don't have to have any engineering experience behind it to be able to use it. That's where visual chatbot building interfaces come into play. So they're usually drag and drop code-free interfaces that offer deploying your chatbots to multiple conversational channels. Uh, they offer native channel message types, so Apple Business Chat will not have the same elements as WhatsApp, for example. And you also have the option to integrate with either external or our internal products. So in Infobip, it looks like this. On the left, we have some kind of organizational units. In our case, they're called dialogues, but you can imagine them as topics. So each dialogue is a specific topic that you want to solve with the chatbot, and in the middle, you will see for that specific topic which elements involved will solve the topic you want to control. In the you have the canvas where you drag and drop the elements, and on the right you will have the list of all the specific elements that you could use. So some of the challenges that arise with such complex interfaces is that the learning curve gets steeper and steeper the more features you add to it. User experience gets really hard to maintain. There are some specialized domain challenges and rules that are specific to each platform that you're using. We have some awards in Android. Then we have the probable availability of common elements in the chatbot, how to maintain it once it becomes too big, and how to remove the static flow of conversation and have it more dynamic and human-like. So the first three is what we try to solve with intent-based copilots. The first thing we did not have a data set. We had a lot of chatbots that are mainly used. So we took 1,000 of them and took the dialogues, the action flows that they had, and we fed them through the LLM to get descriptions. So we created our data set where the input would be the description of the dialogue, and the output will be a 2D array of element types that can be then rendered on the UI. So for this example, this 2D array would look something like this on the UI. So first we did some prompting. We took 4 different prompting strategies, each more complex, and we took 2 at the time state-of-the-art models, so GPT 3.5 Turbo and Gemini 1.2 Pro. Now they're much better ones. But we started with a zero shot where we only gave it instructions of what it should generate. We then expanded with some examples of inputs and outputs. After that, we also added examples of the main rules that we have on the UI, and the latest one was chain of thought, where for each input and output, we explained in steps how the output should be generated. And these are our results from the prompting experiments. So we found that Google Gemini 1.0 Pro is absolutely bad unless it's used with chain of thought. So chain of thought produced the best output with 9% of hallucinations and 5.4% of hit rate. So hallucinations are the percentage of time that the model generated something that we could absolutely not show on the UI. Either it's a syntax error or it breaks one of our rules of the UI that we cannot showcase. And the hit rate is how many times did the model 100% correctly guess each element in our 2D array. So 9% hallucinations was a pretty good score, but it's not something you want to show to the users. So 1 in 10 times something will go bad and we cannot showcase anything. So we also find some models. We took 4 of them, each varying in size. So from the largest one, the GPT, with 7 billion parameters, Llama with 3 billion parameters, and shared llama with 1.3 billion parameters. So we've had the same test data set that we did with the prompting models, and we have found that actually the tiniest model performed the best when it came to hallucinations. But for example, the Mistral that hallucinated the most had the most successful rate of hit rate. So in our artificial testing phase, where we just use the inference APIs and models, we found that shared llama, tiniest of models, and the least expensive one was the most effective to use actually in our product. So now that we artificially tested it, we also did a user study. So we connected these fine-tuned and prompted models to the UI and took our internal chatbot builders, some UX researchers, and tried to see how they would use it and how good it is at actually outputting something that's useful. So we gave the option of selecting the mode of response, which is just a temperature for the model behind some keywords. If it's standard, it's 0. If it's created, it's 0.7 temperature. And we gave them two different models. One prompted one was the GPT, and the two fine-tuned ones, the shared llama and the regular llama. We have found that they had a 66% rate of successful rendering, even though in our artificial testing it was 90%. And that even though their models hallucinated, 90% of the users never changed the model. And that in the future work, we would do the selection of the models offline, somewhere behind the curtains, so the experience is not biased. In conclusion, small models do perform better. They're easier to fine-tune, they're less expensive, and they're easier to specialize. But just because you have a really fine-tuned model does not mean that you know your users. We did not know how the users were using our platform. So in the future, we do plan to actually make a data set that's fully made with human input and not artificially generated. We will specialize, and we also already started working on smaller, more specialized copilots on smaller parts of the platform that will solve our user experience challenges and focus more to reduce the development time before going for something as big as this. And that's it. Thank you. I would just like to say that I have a demo there if you want to catch us after the break session. Thank you.